So we have a question on quadratic functions. We are given the graph of the function. It is at vertex is at 3, 4 and it is a upward opening parabola lying completely above x-axis as can be seen in the diagram. Now we have to write the equation of the axis of the symmetry. Now we know if we have a parabola which is upward opening, the axis of symmetry is a line passing through its vertex, dividing parabola in equal halves. So this will be the axis of symmetry for this particular parabola. And you can see if this is a line which is perpendicular to x, this will be a line x equals to 3. So the axis of symmetry will be at x equals to 3. Now we are given that the function fx can be written as a times x minus h square plus k. Now we know if this is our fx and this equation corresponds to this particular parabola, its vertex will lie at h comma k. You can minimize the value of this fx. It will be at x equals to h and that value will be fx equals to k, and that will be the vertex of the parabola. Hence the value of h will be 3 and k will be 4. So this is your first part of B. Now in the second part of B, we have to find the value of a. Fx we have already identified as a times x minus 3 square plus 4. Now we are also given that 5, 12 is a point lying on this parabola. So fx is 12 and x is 5. So a 5 minus 3 square plus 4. We can solve this equation to get the value of a. So this will be 8 equals to a multiplied by 2 square, which is 4. So the value of a comes out to be 2. Needless to say, it is a positive value as we already know the parabola is upward facing. Now in the C part, we have to draw a tangent at point 5, 12. Now fx is completely known. This is 2 times x minus 3 square plus 4. Now to get the equation of the line, we know a point. We have to get the slope. Slope will be first derivative f dash x, which is 4 times x minus 3. Now putting x equals to 5, we can get the slope. Slope will be 4 times 5 minus 3, that is 8. So you can easily write the equation of line. That will be y minus 12 divided by x minus 5 equals to, this will be y minus 12 equals to 8 times x minus 5. So you can simplify this, equals to y equals to 8x minus 40 plus 12. So the equation of the tangent will be y equals to 8x minus 28. So this is the equation of the tangent at a particular point P. Now moving on to the next part. In the D part, we have to find the values of D for which g is an increasing function. The function gx is defined such that its first derivative is equals to fx minus d. Now for gx to be an increasing function, we know g dash x has to be greater than 0. That means fx minus d has to be greater than 0. Now you know the graph of fx is such that its vertex is at 3, 4. That means the lowest value of fx is 4. So if you are subtracting a d and it has to be positive overall, so you must know that the d must be such that this vertex remains above x-axis always. So what we will do is we will do 4 minus d greater than 0. This will ensure that this vertex remains above x-axis always. So d is less than 4 is your solution. Moving on to the next part. In the next part, we have to find the values of x for which graph is concave up. Now gx is concave up when g double dash x or the second derivative of z is greater than 0. Now we already know g dash x, which is fx minus d. So second derivative will be f dash x greater than 0. Now fx is 2 times x minus 3 square plus 4. So its first derivative will be 4 times x minus 3, and this has to be greater than 0 for gx to be concave up. So this is x greater than 3. So for all values of x greater than 3, gx is a graph which will be concave up. So this is your solution, and for more such questions and their detailed explanations, keep visiting our website iitnacademy.com and do not forget to register. Thank you.